everyone, welcome to Crack Easy, the place to learn how to crack easy exams. It's me Abhisha. In this video, we are going to continue our discussion on detailed solution of NIELIT Scientist B job exam conducted in July 2017. So keep watching this lesson with me where I'm going to share not only the answers but also all the concepts related to each questions. Hope all set to get started. Let me now take you to the first question. In 2's complement system, add the sign numbers 11110010 and 11110011. Determine in decimal the sign and value of each number and the sum. Four options are given. Option A, minus 14 and minus 13, minus 27. Option B, minus 13 and minus 12, minus 25. Option C, minus 27 and minus 13, minus 40. Option D, minus 2 and minus 3, minus 5. Let us first understand all the basic concepts which is essential to solve this particular question. Starting with number system. As you know, it is the most basic topic of digital electronics. Now have a look at three characteristics that define a number system. First one, number of independent digits or symbols used in a number system. In fact, it is the most fundamental characteristics of a number system which is known as radix or base of that system. For example, consider the decimal number system with which we all are familiar. It is having a radix 10. Now can anyone tell me these 10 independent digits or symbols used in decimal number system? It is nothing but 0, 1, 2, 3 up to 9. On the other hand, binary number system is having two independent symbols or digits. They are 0 and 1. So it is a radix 2 system. Alright. In fact, the radix or base of a number system determines the remaining two characteristics of it. That's what we are going to look at next. The second characteristic, place value. The place values of different digits in the integer part of a number are r⁻0, r⁻1, r⁻2, etc. starting with the digit next to radix point. On the other hand, for fractional part, these are r⁻⁻1, r⁻⁻2, r⁻⁻3, etc. Again, starting with the digit adjacent to radix point. Finally, the maximum numbers that can be written with n digits in a number system is given by r⁻n, and this is the third characteristics where r is the radix. That's all I want to say about number system. Switching focus to how to find out 1's complement and 2's complement of binary numbers. In fact, you should have a clear picture of these concepts to solve our problem. So please listen carefully. First one, 1's complement. The 1's complement of a binary number can be obtained by complementing all its bits. That is, replacing all zeros with 1 and all ones with zeros. Let us understand this concept better with an example. Here you can see a binary number 1001. Now you just pause the video and try to find out its 1's complement yourself. Got it? When we replace all ones with a 0 and all zeros with 1, we get its 1's complement as 01110. Alright? One more example. The 1's complement of 11001 is 00110. It is obtained by replacing all ones in this particular binary number with zeros and all zeros in this particular binary number with 1. Clear? Moving on to 2's complement. The 2's complement of a binary number can be obtained by adding 1 to its 1's complement. So for obtaining 2's complement of a binary number, first we have to find out its 1's complement, then add 1 to it. Now look at this binary number 10001. Now we are going to find out its 2's complement. As I said earlier, first we have to obtain its 1's complement by replacing all 1's with zeros and all zeros with 1. Correspondingly, we get the 1's complement as 0, 1, 1, 1, 0. Then we had to add 1 to it. Here, the addition is to be performed based on basic laws of binary addition. Correspondingly, we get 0, 1, 1, 1, 1. Moving on to number representation in binary. Basically, we have 3 types of representations. They are sign bit magnitude representation, 1's complement representation, and 2's complement representation. Here we are going to focus on 2's complement representation since it is related to our question. In 2's complement representation, the MSB or most significant bit represents the sign of a number. Got it? A 0 at MSB denotes plus sign and a 1 at MSB denotes minus sign. The remaining bits are used to represent magnitude of the number. For example, consider an 8-bit system. Here, MSB represents sign of the number and remaining 7 bits are used to represent magnitude of the number. Got it? If the number is positive, then MSB in its 2's complement representation will be 0 and its magnitude part will be binary representation of the number. On the other hand, if the number is negative, then the MSB in its 2's complement representation will be 1 and its magnitude part will be 2's complement of binary representation of the number. I think this concept is a little bit confusing, but don't worry, I will make a more clear picture with an example. So we are going to find out 2's complement representation of plus 9. Since it is a positive number, the MSB in its 2's complement representation will be 0 and remaining 7 bits will be binary representation of 9. So we got the 2's complement representation of plus 9 as 0, 0, 0, 0, 1, 0, 0, 1. Here this 0 at MSB is the sign bit and these 7 bits are binary representation of 9. Let us now find out 2's complement representation of minus 9. Here also we are considering 8-bit system. Since this is a negative number, the MSB in 2's complement representation will be 1 and remaining 7 bits will be 2's complement of binary representation of 9. As you know, this is 7-bit binary representation of 9, 0, 0, 0, 1, 0, 0, 1. When we replace all zeros here with 1 and all ones with a 0, we get 1's complement of 9. That is given here 1, 1, 1, 1, 0, 1, 1, 0. This 1 denotes the sign bit and these 7 bits are 1's complement of 9. Then we add plus 1 to this 1's complement. This addition is to be performed based on basic laws of binary addition. So we get the 2's complement of minus 9 as 1, 1, 1, 1, 0, 1, 1, 1. The MSB represents sign bit and the remaining 7 bits are 2's complement of binary representation of 9. Hope you got a clear picture of 2's complement representation. Switching focus to how to perform addition using 2's complement method. Let us first focus on the steps to be followed. In first step, we have to express the numbers to be added in 2's complement form. Then add these numbers based on basic laws of binary addition. If there is any carry generated out of MSB, that should be disregarded. One more thing we should always keep in mind that the result of the addition will be in 2's complement form. Got it? In fact, our question is to perform addition of two numbers using 2's complement method, but I think it's better to understand this procedure of addition based on some simple examples, then focus on our question. So here we are going to add two decimal numbers 5 and 6 using 2's complement addition. As I said to you earlier, in first step we are supposed to express the numbers to be added in 2's complement form. So let us first find out 2's complement of 5. Since it is a positive number, the MSB in 2's complement representation will be 0 and remaining 7 bits will be binary representation of 5, which is nothing but 0000101. Similarly, you can see 6. It is also a positive number. Correspondingly, the MSB in its 2's complement representation will be 0 and remaining 7 bits will be binary representation of 6. So we get 0000110. Got it? Next, what we are supposed to do? We have to add these two numbers based on basic laws of binary addition. That's what we are going to do next. So we add the 2's complement representation of 5 and that of 6 based on basic laws of binary addition and get the result as 0001011. Since there is no carry generated out of MSB, we don't want to bother about third step. Finally, our result is in 2's complement form. So let us find out the decimal number corresponding to this result. Now you look at this MSB, you can see it is 0, and from this we can conclude that the result is a positive number and its magnitude part will be binary representation of that number. Here the magnitude part is 0001011 and the corresponding decimal number is 11. Got it? Let us try one more example. Here we are going to add two numbers 5 and minus 6 using 2's complement method. As I said earlier, in first step we are supposed to express these two numbers in 2's complement form. The 2's complement representation of plus 5 is already found out as 0000101. Let us now focus on 2's complement representation of minus 6. Since it is a negative number, the MSB in 2's complement representation will be 1 and remaining 7 bits will be 2's complement of binary representation of 6. As you know, 0000110 is the 7-bit binary representation of 6. When we replace all zeros here with 1 and all ones with 0, we get 1's complement of 6 as 1111001. Then we add 1 to this 1's complement based on basic laws of binary addition and get the result as 1111010. Finally, we append the sign bit 1 at MSB and get 2's complement representation of minus 6 as 11111010. Clear? In next step, we are supposed to add these two 2's complement representation based on basic laws of binary addition. So you can see here, this is 2's complement representation of plus y and this is 2's complement representation of minus 6. When we add these two numbers based on basic laws of binary addition, we get the result as 11111111. Since there is no carry generated out of MSB, we don't want to bother about that. But one thing we should always keep in mind that our result will be in 2's complement form. So let us find out the decimal number corresponding to this result. Now you look at this MSB. Since MSB is 1, we can conclude that result is a negative number and the 7 bits represent 2's complement of binary representation of the result. Alright, let us now find out the decimal number corresponding to this result. So first we replace all ones here with a 0 and we get ones complement as 0, 0, 0, 0, 0, 0, 0. Then we add 1 to ones complement based on basic laws of binary addition and get the result as 0, 0, 0, 0, 0, 0, 1. Now can anyone tell me the decimal number corresponding to this 7-bit binary? It is nothing but 1. Then finally appending the sign bit we get the result of addition as -1. Clear? Thus we discussed all the concepts which are essential to solve this particular problem. So it's a time to go back to our question. In fact, we are asked to perform addition of two numbers and the numbers to be added are given in the 2's complement representation. We are also supposed to find out decimal equivalent of these two numbers. Alright, let us first focus on finding out decimal equivalent of numbers to be added. The first number is given as 1111010. Now you look at this MSB. Since the MSB is 1, it is clear that this is a negative number and the remaining 7 bits are 2's complement of binary representation of that number. So here the MSB is written in red color and the remaining 7 bits are separated here. When we replace all zeros here with a 1 and all ones with a 0, we get the ones complement as 0001101. Then by adding 1 to it based on basic laws of binary addition, we get the binary representation of the number as 0001110. So this is the binary representation of the magnitude. Now can anyone tell me the decimal equivalent of this binary number? It is nothing but 14. Then by appending this sign we get it as -14. Moving on to second number, it is given as 11110011. Since the MSB is 1, it is clear that this is a negative number and the remaining 7 bits are 2's complement of binary representation of the number. Here also I marked the MSB in red color and remaining 7 bits are separated here. When we replace all ones here with a 0 and all zeros with a 1, we get the ones complement as 0001100. Next we add a 1 to it based on basic laws of binary addition and get the result as 0001101. In fact, this is the binary representation of magnitude of that particular number. Now can anyone tell me what is the decimal equivalent of this binary number? It is nothing but 13. Then by appending this sign we get the result as -13. Clear? Our next task is to perform addition of these two numbers using 2's complement method. Hope you remember the steps to be followed for performing 2's complement addition. Since the numbers to be added are already given in 2's complement representation, we don't want to perform first step. So starting from second step, that is adding 2's complement representation of the two numbers based on basic laws of binary addition, we get a result 1111000101. Here a carry is generated out of MSB and it should be disregarded. Correspondingly, our result becomes 11100101. In fact, this is 2's complement representation of sum. So we have to find out decimal equivalent of this number. That's what we are going to do next. Since the MSB is 1, it is a negative number and remaining 7 bits are 2's complement of binary representation of that number. So we separated these 7 bits here. Then by replacing all ones here with 0 and all zeros here with 1, we get ones complement as 0011010. Next we add a 1 to it based on basic laws of binary addition and get a result 0011011. In fact, this is the binary representation of magnitude of sum. It is clear that the decimal equivalent of this binary number is 27. Finally, by appending the sign, we get sum as minus 27. Thus, our answer is option A, minus 14 and minus 13 minus 27. Moving forward to second question. A 4-bit R to R digital to analog converter has a reference of 5 volts. What is the analog output for the input code 0101? 4 options are given. Option A, 0.3125 volts. Option B, 3.125 volts. Option C, 0.78125 volts. And option D, none of the above options. First of all, let me ask you a question. Do you know what is a DAC? In fact, a DAC converts digital signal into its equivalent analog signal. You can see the schematic diagram of a DAC here. At the input side, we have n-bit binary signal B0, B1, etc. Bn-1. This n-bit binary is combined with this reference voltage VR to give an analog signal at the output side. The output of a DAC can be either voltage or current. Basically, we have two types of DAC. They are weighted resistor DAC and R2R ladder type DAC. Since our question is related to R2R ladder type DAC, let us concentrate more on this. It's the most popular type of DAC. Circuit diagram is given here. You can see a ladder network containing series parallel combination of two resistors R and 2R. When we apply an n-bit binary signal D0, D1, etc. Dn-1 here, an equivalent analog voltage is produced here. The output voltage of an n-bit DAC can be expressed as V0 is equal to D0 E by 2 raised to n plus D1 E by 2 raised to n minus 1 plus etc. plus Dn minus 2 E by 2 raised to 2 plus Dn minus 1 E by 2 raised to 1, where V0 is the output voltage, E is the reference voltage, D0, D1, etc. Dn minus 1 is the n-bit binary input. Got it? Coming back to our question, it is given that reference voltage is 5 volts, n equal to 4, and the binary input is 0101, that is D01, D10, D21, D3 equal to 0. By substituting these values, we get the value of output voltage as 1.5625 volts. Thus, our answer is option D, none of the above. So, in this lesson, you have learned all concepts related to these two questions. If you have any doubts regarding this, please do let me know in comment section. Apart from that, try to practice maximum questions so that you will be prepared in such a way that you can answer any question based on this topic without making errors. Hope this lesson really turns out to be productive for you. Come back soon for another lesson with me on Crack Easy. Thanks for watching. Thank you.